Welcome to my talk about Osint. A lot of knowledge nowadays can be found online on the World Wide Web. Even knowledge which can help you find security issues or vulnerabilities in a target you are testing. I will try to explain what Osint is and how you can use this in your advantage when testing for bug bounty targets. Instead of doing Osint manually, there are tools available too. Some of these tools will be highlighted in this talk, with some examples on how to use them. I will end my talk with some Osint examples, which resulted in submissions with quite some impact. Before I'm going to tell you about Osint, I would like to introduce myself a little bit more. I'm Sander Wind, 29 years old and living in the Netherlands. I'm a full-time web developer for more than 10 years and primarily programming in PHP. Last year, I started my own security company called Mission Control. My main goal is to educate companies and programmers about developing secure applications. When I'm not working or spending my time with friends and family, I like to hunt for bugs on Intigriti. So enough about me, let's get started with Osint. So what is Osint? Osint is an abbreviation for Open Source Intelligence. In short, Osint means that gathering data available from open sources can be used to get a better understanding of the target you are testing. Osint is not only used for bug bounty, but also by researchers in other fields. For example, law enforcement. They use social media to get more information about a suspect. Also, with journalism. Videos shared on social media can be verified by looking up the exact location on Google Maps. At this very moment, it's also happening with a lot of images and videos about the war in Ukraine. To give you an idea of Osint and how it can be used by journalists, I will tell something about one of the Bellingcat's published articles about the investigation on MH17. Bellingcat was able to verify the identity of a key person in the investigation, which is also one of the top officials within Russia's FSB security service. This is Colonel General Andrei Ivanovich Burlaka. When they did a reversed image search on Andrei Burlaka, his face, they found a television set for sale in an online advertisement, which showed Andrei Burlaka appearing in a television show. The date of the television show appeared to be the same as the creation date of the online advertisement. Because of the television show, Bellingcat was now able to verify the voice of Andrei Burlaka to be the same voice as the person Vladimir Ivanovich in one of the intercepted phone calls published by the Dutch-led Joint Investigation Team. I think a lot of researchers are using Osint already, but are not even aware of it. For example, when doing recon and scanning for subdomains, there is a big chance that the discovered subdomains are retrieved by open source data available on the internet. So, how can you use Osint for bug bounty? And what Osint tools are available for recon automation? A few examples of Osint. As told in the previous slide, there is a big chance that the recon you are doing on domains and subdomains is highly dependent on Osint. To give you an example on this, let's have a look at the website cert.sh. Cert.sh is a search tool to look up certificates which have been logged by certificate transparency. By querying for a domain, you can find subdomains of the target where a certificate has been issued for. Also, querying for details about certificates is possible with this tool too, like organization names. This way, you can find domains which are related to your target but not specifically listed as an in-scope asset of the program. A great service for looking up information about DNS data is Security Trails. Security Trails keeps track of DNS data of a lot of domains. This data includes subdomains, but also historical data. The latter can be used to circumvent web application filters by directly accessing a former known IP address of the domain you're looking up. That way, you could still test for SQL injection attacks that would otherwise be blocked by the web application filter. Crawling all URLs on a website can be time-consuming. Also, old URLs, which still work, can be interesting to have a look at. To explore these URLs, you can use the Wayback Machine. As you can see, when querying for Intigriti.com, a lot of URLs are being returned. These URLs can contain sensitive documents and endpoints you were not aware of. And remember, URLs who might not work on the live website anymore can still contain sensitive information on the indexed page in the Wayback Machine. Source code, for example hosted on GitHub, can give you new information about your target. Searching in GitHub for a domain can give you interesting results containing new subdomains or URLs. A lot of valuable data can be found in the source code of applications. A common mistake to be found in source code are hard-coded credentials. Found credentials can lead to access to authenticated systems containing sensitive data. I'll give you an example. Last year in July, a guy called August found a GitHub access token after extracting the source code from an Electron app. It appeared that his access token gave August read and write access to Shopify-owned GitHub repositories. Even though August wasn't specifically testing Shopify, this example does show the impact of an access token leaked by an employee. By inspecting source code, you can even find programming flaws. These flaws can lead to new vulnerabilities, a CVE, and even a new zero-day. This is something I discovered myself in Moodle and ended up to be my first CVE. After looking into the source code of Moodle, I found out that the endpoint for validating an email address after creating an account wasn't properly validating the input of the validation token in the JSON payload of the request. This made it possible to create an account for any email address you want and use a validation token with the Boolean value true to validate it. A nice way to find credentials in source code is by using the search engine of GitHub. You will be amazed by how many repositories contain access tokens or other sensitive credentials which shouldn't be open source. Those credentials can give you access to authorized systems. When looking for sensitive data for your target, try querying the domain name of the target with keywords like password, username, or token. Also, look for users which are employees of the target. They sometimes publish code on GitHub which contains sensitive information which can be used to access their employers' projects. The next one is Gitlab. Gitlab is a bit more hardened on code searches, but it has a nice endpoint which is often forgotten by companies to block access to it. If you find a Gitlab instance for your target, Try the Explore endpoint. This endpoint lists public repositories and snippets which are often accessible without the need for authentication or authorization. Sometimes you will find sensitive data in these listed repositories and snippets. And then there is Stack Overflow. Stack Overflow does help a lot when you're stuck while programming. Complete code examples are sometimes being posted to help each other out. But when programmers are struggling, they tend to forget removing sensible details about the project they are working on. And before they know, they posted sensitive data in their question on Stack Overflow. Sometimes complete debug logs are being posted containing loads of information about your target, including passwords or access tokens. Even when a vulnerability has been patched, you might be able to create an exploit based on the patch applied on the source code. And don't forget to check the mobile applications of your target. A lot of Android applications can be downloaded from services like apkpure.com. When you download the application, extract it with a tool like JetX, and check the source code for sensitive data. Within this data could be API endpoints being available without authentication or authorization, but also credentials for other services like Firebase notification services or databases can be present in the source code of an Android application. Search engines can be really powerful tools to use, as they index loads of information and making it easy to search through that information. Google is the biggest search engine to be found on the internet and can be used to find sensitive information of your target using Google Docs. Using Google Docs is as easy to use the advanced search functionality of Google. It gives you a lot of power when searching for sensitive data of your target. For example, an Excel file containing email addresses of customers is never a good thing to have publicly available on a website. To discover such Excel files, you can use this dark. In this example, I'm looking for the site target.com and searching for files with the type XLS, so Excel files. Also, the Excel files should be hosted on a URL which contains email. Searching for the text username in index log files can be accomplished by using this dark. I'm searching for the site target.com with file types of log. In these files should be the text username. If you find such files via Google, there is a big chance that passwords are in those log files too. Another really useful search engine is Shodan. Shodan is not a typical search engine, but it lets you search for a lot more than only web service. It gives you the power to search for online services using a lot of different filters. A few examples of these filters are given out SSL certificates, but also Bitcoin addresses, and you can look for HTTP titles in the response of a service. In this specific example, I searched for services running on port 80 with the text Bug Bounty Hunter in the HTTP title. You can also use Shodan to search for services which aren't default websites. For example, you can search for webcams connected to the internet. Would be really cool if your next submission is about an accessible webcam inside the company building of your target. Documentation is key. It's not only applicable when programming software, but also for discovering useful information about your target. Bug bounty reports and write-ups are really useful to learn new stuff about the software your target is using. Think about common pitfalls or how to abuse a vulnerability in an outdated software product which has been exploited by someone else before. Also, search for keynotes and knowledge bases of companies and their employees. In these keynotes and knowledge bases are often images which contain sensitive data, like domains, subdomains, and URLs. When watching a keynote, look for speakers using their web browser. Sometimes the autocomplete of the URL bar is giving away sensitive information like Google document URLs or even internal domain names. Most software has online documentation available. In this documentation is often explained how software can be installed and configured. Try looking for default configurations, which can be dangerous to be left in a production environment. Think about default login credentials or API endpoints which expose sensitive information. Also, reading documentation can help you with abusing functionality which can be exploited when not implemented properly. For example, PDF generators. They often support HTML code or placeholders to convert input to a PDF document. If you find such generators, look up the documentation and try to trick the PDF generator in including special payloads, like including local files or AWS metadata services. To make life easier, there are tools available to do the hard work for you. The first tool I would like to highlight is Ams. Ams is an amazing tool to discover additional domains, subdomains, and IPs belonging to your target. It is using different techniques to gather available information from open sources across the internet. Some of these techniques are DNS queries, certificate lookups, and brute forcing subdomains. At this very moment, Ams is using approximately 90 sources to gather its information. Cert.sh and Wayback Machine, which I talked about earlier in this talk, are also one of the many sources available. Some of these sources require you to register an account or take a subscription. But no worries, even without those subscriptions or accounts, you can get a lot of valuable data. For example, to get a list of domains which are related to your target domain, you can use the Intel module in Ams. It will look up voice entries which are related to the given domain name. If you want to get even more intel, provide the active flag. This way, Ams will try to grab certificates and check for alternative server names. The Ams enumeration module will look up DNS entries for the given domains. If you want Ams to check if the found domains are active, provide the active flag. Brute forcing subdomains can be done by providing an additional word list via the brute and the W flag. The Ams Track Module shows you what exactly changed in the discovered enumeration results. This can be used to create alerts for your recon automation. This way, you are always one step ahead of other researchers. The second tool I want to highlight is GAU. GAU stands for Get All URLs and lets you discover URLs using several sources, like Alien Vault's Open Thread Exchange and the Wayback Machine. It does have the option to gather subdomains too. Filtering and matching response codes or MIME types is also one of the many available options. To get a list of URLs of Intigriti.com, including its subdomains, you can use the subs flag. Filtering on the response code can be done with the MC flag. In this example, I'm saving the results to a file called urls.txt and checking the amount of results after Go is finished. Go found 4,339 URLs, and after filtering for specific JavaScript files, only 184 URLs are left. Looking specifically for JavaScript files can be useful because they often contain URLs and endpoints. On GitHub, a lot of secrets can be found, but searching for them via the web interface can be a time-consuming and boring job. To make life easier, there is a tool called Git All Secrets. Git All Secrets lets you search GitHub for secrets hidden in repositories. It will clone repositories to your local machine and do a full scan on the files and their changes in history. This tool also gives you the possibility to search secrets in all repositories of an organization and its employees. This way, you do not need to search for all those repositories yourself. The easiest way to run Git All Secrets is with Docker. Make sure you have created a GitHub token to use with this tool. In this example, I'm targeting InnoGames. You'll download all public repositories of InnoGames and the repositories and gists of its employees. After that, it will start looking for secrets. Unfortunately, as it can take quite a while, I will not show the full process of running Git All Secrets, but jump right away to the results. When Git All Secrets is finished, you can copy the results from the Docker machine and look for interesting secrets. In this example, you can see that Git All Secrets found hints on hard-coded passwords being used in the source code. Also, the existence of Slack tokens has been logged by the tool. To wrap things up, I would like to give some examples which have been found by myself purely using Osint. When I searched GitHub for a domain name of a target, I found a GitHub repository containing database credentials. After connecting to the database, I was presented a list of tables which contained more than 40 million records in total. Amongst these records, also personal identifiable information was present. During a collaboration with two fellow researchers, I found an access token on GitHub. This access token gave us root access to more than 2,000 cloud servers of a big hosting company. While searching for a domain name of a target, I found a repository of an employee from another hosting company. In this repository, a password was present which also was being used to access the management systems of the hosting company. And one of the nicest examples of Osint I encountered myself was during another collaboration. We were able to abuse functionality which was described in the online documentation of a PDF generator. This functionality gave us the possibility to perform server-side requests and made it possible to query internal domains. The internal domains were discovered by security trails. When requesting these internal domains, we got access to data of all customers. So remember, your next submission is just a Google away. Enjoy the other talks on this amazing conference hosted by Intigriti. Much love and thanks for listening.